So that's one example of using the chain rule, how it's helpful. Another is when you don't know what the functions are, but you know some of their values. So let's say that f of x is a composition of two functions. So f of x is equal to maybe g of h of x. And we know some information about them. We know that h of 5 is 7. We know that h prime of 5 is 12. And we know that g prime of 7 is 1/2. So this is information we know somehow. We've gathered it from data or it's just been given to us. And the question is, well, what is the derivative of f? What's its rate of change when x is 5? So what is f prime of 5 equal to? So at first blush, you may not know how to even approach this problem because I don't know anything about f except for that it is a composition of two functions. I know it's the composition of two functions, but I don't even know what those functions are. All I know is that h of 5 is 7, h prime of 5 is 12, and g prime of 7 is 1/2. But the chain rule tells us exactly how to do this because by the chain rule, f prime of x is the derivative of the outside function. So that's g. So it's g prime evaluated at h of x times the derivative of the inner function. So that's h prime of x. So this is our chain rule. That's just what the chain rule says. And so f prime of 5 would be g prime of h of 5 times h prime of 5. And h of 5 we know is 7. And h prime of 5 is 12. So this is g prime of 7 times 12. And we know what g prime of 7 is. 1/2, lucky for us. So this is 1/2 times 12, which is 6. So even though we didn't know the exact function for f or g or h, we just had a little bit of information, and that was enough to tell us what the derivative of f at 5 is. It will be 6. So this last problem involves using parametric equations. So let's say that a particle travels according to some rule that its x-coordinate changes or is equal to t squared plus 1. So at any given time, we know what the x-coordinate is, and similarly, that its y-coordinate is equal to 3t cubed. So before we start this key problem, I just want to explore or remind you how to think about parametric equations. So we'll flip over to the graph in Desmos and look at a particle whose x-coordinate is equal to t squared plus 1 and y-coordinate is equal to 3t cubed. And in this animation, we'll let time move forward, and we see the particle starts at the origin and shoots straight up. And we can even plot what the path of this particle is. It follows a predicted path denoted by these dashed lines. So this is what the particle looks like according to this parametric equation. The question that I would like to ask is when time is equal to 2 and the particle is fixed at this point, we have the path it's on, and the question is, what is the slope of the path of this particle at that point? What is the slope? And so slope is always about infinitesimal form, so I'm going to zoom weigh in and take a close look. Um, and so we want to know what is the slope of the path of this particle. So what is the slope of this curve? Now we don't know what that curve is in terms of y and x. We just know what the y coordinate and the x coordinate is. But nonetheless, we know how to compute slope. It's our change in y. Let me zoom in a little bit more. That's kind of too far out. But change in y, which is simply the differential of y, and the change in x is the differential of x, and then our slope is simply change in y over change in x, which is dy dx, or the differential of y over the differential of x. So this gives us a strategy that if I want to know the slope of the path of this particle, I can look at it by calculating the differential of y and the differential of x and take their ratio. So back to our blackboard, we want to calculate the slope of the path of the particle when time is equal to 2, or t is equal to 2. And from the graph we just looked at, we know that the slope will be the change in y over the change in x. Again, nothing surprising there. But what is the differential of y? Well, y is 3t cubed, so the differential of y is the differential of 3t cubed, which is the 3 times the differential of t cubed, which is equal to 3 times 3t squared dt, or 9t squared dt. And what is the differential of x? Well, the differential of x is the differential of t squared plus 1, which is the differential of t squared plus the differential of 1, which is 2t dt. So then our slope is the ratio of those two differentials. So our slope, m, which is dy dx, which is 9t squared dt divided by 2t dt. And we see that our differentials of t, they cancel out. And we get simplification here. And so the differential of y with respect to x is equal to 9 halves t. So what is the slope of our path when t equals 2? Well, dy dx when t equals 2 is equal to 9 halves times 2, which is 9. And that's the slope of our path.